Today we're going to look at graphing quadratics. Hopefully we're going to connect with what we did yesterday to what we're doing today. I want to see how roots and solutions and zeros all match with what we know to be true on the graph. Once again, vocabulary-wise, the idea of a root, those are also called x-intercepts. Those are also called zeros of the function. It is where our function touches the x-axis. The other important things that we need to know about parabolas. The most important point is the vertex. We also have things that happen at the vertex. We have something that's called an axis of symmetry, which means the graph is symmetrical on both sides of that. Another thing that occurs at the vertex on a parabola is what's called a maximum or minimum value. We are talking about y values on maximums and minimums, and if our parabola opens up like this one does, then we will have a minimum y value. In other words, at no time whatsoever will my values of y get any lower than my vertex point. Another key piece of information that usually is given to us for free is the y-intercept, and that's where the graph touches the y-axis at. Y-intercept touches the y-axis. X-intercept, those are the solutions, those are the roots, those are the anchors, those are the points that the parabola goes through the graph at. Vertex, there's several different ways to find the vertex. We'll look at those today. Most important point, axis symmetry, that's the thing that we mirror across, and you should be able to see that visually here, what happens. And also you should be able to see that the idea of that maximum and minimum value. If we're looking at our y values, at no time whatsoever are we going to get any lower than that value of, what is it, -4 on this graph for y. So that will be my minimum value. Okay, that's your vocab. Let's see how it relates to an actual graph here. We're looking at f of x equals x squared minus 6x plus 12. Piece of information, if it's asking us to graph what we need, x-intercepts, y-intercepts, vertex, axis of symmetry, domain and range. I always play Docker at the end. I get everything else down that I know first. There's one piece of information they give me for free. This is a quadratic in standard form. When I have a quadratic in standard form, they've given me the y-intercept for free. So I'm going to put that piece of information down right now, and that is 0, positive 12. Next thing I'd like to know is my vertex and my axis of symmetry. When I have a equation in standard form, my vertex, or the x value of my vertex, can always be found at this location, x equals -b over 2a. That is also the equation for our axis of symmetry. So in this case, -b over 2a, that is a -6 over 2 times 1. Remember, standard form of a quadratic is ax squared plus bx plus c. That gives us 6 over 2, which is 3. So our axis of symmetry, x equals 3. Our vertex, we don't know our vertex yet. We just know the x-coordinate of our vertex. Again, we have a axis of symmetry at x equals 3. We know that we're symmetric across that. We also know that our vertex is at 3 comma something. We don't know what the y value is, but we can find that out. We do need to substitute back in to find what y is, or in this case, what f of 3 is. F of 3, that's plugging in our x value to every x location we see. That is 3 squared minus 6 times 3 plus 12. F of 3 equals 9 minus 18 plus 12. F of 3, in this case, is going to equal, what do we got there? 9 plus 12 is 21. 21 minus 18 is 3. So that is now the y value of our vertex. F of x, or f of 3 is 3. We now have our vertex, as I said. Vertex is the single most important point on your parabola. So positive 3 for us. That's our vertex. Next thing I want to look at this, f of x equals x squared minus 6x plus 12. Hopefully you're thinking to yourself, does this parabola open up or down? Hopefully you just answered to the video, it opens up. We know that because this is positive. Positive means it opens up. A little reminder about that thing called end behavior. That's a degree of 2. We're up at both ends. It's positive. So we're opening up here. So, Mr. Wood, you said that x-intercepts were important, and I should always find them. Those are the roots. It's where the parabola is anchored to the x-axis at. Well, in this case, on this problem, this parabola is never going to touch my x-axis. It's never going to touch it. It's opening up. And it's going to be, my vertex is my minimum value, so that y value is never going to get lower than 3. So it should make sense to you when I tell you, hey, there's no x-intercepts in this problem. It means there's no real roots in this problem. It means that if you solve this quadratic equation using the quadratic equation, the quadratic formula from yesterday, you will get imaginary roots in there. You're going to have i's, and it should make sense to you that you would get imaginary root because this parabola is not going to touch the x-axis. In fact, we can see it here. 0, positive 12, 0, positive 12. It's going to be about there. It's not quite on my graph. That's my y-intercept. What I will do to get my other point and to get this parabola graphed, I will mirror that over 1, 2, 3, 1, 2, 3. I'll mirror it over 3 locations. Now I will connect the dots, and I have my parabola graphed. Wow, Mr. Wood, that parabola sure doesn't go through the x-axis. I know it doesn't. It's not supposed to. You're supposed to know that. No real roots, that's why we have no x-intercepts. Gee, that almost makes sense. Yes, I know. It's supposed to. Last thing we have to do here, we've got it graphed. Hopefully see the connections. Hopefully we're okay with how the vertex came to be. Play doctor, that's domain and range. Domain is always talking about our x values. Range is always talking about our y values. So in this case, x can equal anything in the world. We can plug anything we want in for our x value. And then our range, which is our y values. Y is going to be greater than or equal to 3. Again, that comes from our vertex. That also comes from the domain restriction is always going to come from our maximum or minimum value. Again, should make sense to you that this parabola, if I'm talking about y's, that's my vertical axes, this parabola is never going to go lower than this y value right here. That y value is y equals positive 3. So when I say range, I'm telling whoever's reading my work what y can be. In this case, y can be anything greater than or equal to positive 3. There you go. Next up. Another parabola, standard form, f of x equals negative x squared plus 10x minus 21. We're still looking at everything that we need to have. I'll pull that down just a second. There we go. We're still looking for x-intercepts. We're still looking for the y-intercept. They do give me that for free on this problem. I need the vertex, I need my axis symmetry, and I need my domain and range. Those things we always need when we're graphing. We can get all that information from this graph here. First thing I'm going to go with is what they give me for free, which is my y-intercept. My y-intercept is 0, negative 21. Before I get farther, I want to talk about the shape. Again, my degree is even. It's negative. Hopefully you agree with me that this is going to be a parabola that faces down. It means both ends of my parabolas go down. Next up, I'm going to go ahead and find my vertex. My vertex will always be found when I have an equation in standard form, which this one is. My vertex or my axis of symmetry will always be at negative b over 2a. In this case, that's a negative 10 over 2 times negative 1. It's negative 10 over negative 2, which is a positive 5. So my axis of symmetry will be at x equals 5. That is also the x value of my vertex. My axis of symmetry will be at x equals positive 5. To find the y value of my vertex, I need to plug it into my function. I need to now find f of 5. That will be negative 5 squared plus 10 times 5 minus 21. F of 5 will be 5 times 5 is 25. That will be a negative of that. So that will be negative 25 plus 50 minus 21. So f of 5 becomes negative 46 plus 50. And f of 5 will become, what do we got there? Positive 4. So my vertex is at positive 4. So I'm going to plot that. My vertex is at positive 5, positive 4, positive 5, positive 4. My other information that I have is my y-intercept at 0, negative 21. That's way down here off my graph. I'm going to put that right there, 0, negative 21. I'm now going to go ahead and mirror that across. It's 5 units and 5 units. That's kind of off my graph over there too. But we know that this parabola shapes down. We know that we have the end behavior correctly. I do have to connect the dots, but right now we can see with my vertex being above the x-axis and my y-intercept being below, that tells me I do have roots on this parabola. And so if we have roots, if we have x-intercepts, we need to find them. So the next part I need to do is find my x-intercepts. The way that I'm going to find my x-intercepts is I'm going to try to factor that. I factor it. That's going to be negative times a negative for positive 21. Negative 1 times negative 21 is positive 21. And bring down my 10. Up top, I'm going to set it up as negative x and negative x. And now I'm going to try to come up with two numbers that multiply together to give me 21 and add together to give me 10. Those numbers should be positive 7. And what do we got? Positive 3. So now I have my factors. If I didn't factor this correctly, what do we got? I made a mistake somewhere. Where did I make my mistake? Hold on, I'm going to pause the video while I find it. Okay, I found it. Here's what we need to do for this problem, because it is factorable, and we'll make sure we get the roots into it. Kind of look at the beginning and kind of compare it to the next example that we're going to do here, and that is to say this. If I want to change this from standard form, which is ax squared plus bx plus c, that's what we have right now. If I want to write it in intercept form, I want to get what's called linear factors. Those are binomials. I'm going to write it in factored form. First thing that I'm going to do is divide out that negative here. And I'll show you why in just a sec when we get our answer. When I divide out that negative, I'm going to go ahead and factor my quadratic, which is going to be 21 and negative 10, x over, x over. And the answers that are going to work here should be negative 7 and negative 3. Now I want to write this in factor form. Some of you guys can already see the roots here, but I just want to show you that what we're doing is going from standard form, which is ax squared plus bx plus c, into intercept form. And remember, intercept form gives us our roots, and that's why I had to divide out that negative, because the negative is talking to me about how that graph is shaped. Is it going up? Is it going down? So I want to pull that out, and now I can still have my roots. Again, opposite x, we can set that equal to 0 and solve very much like we did yesterday. I think you guys will see that this gives us x equals 7 for a root and x equals 3 for a root. So our intercepts, again, are at 7, 0, and 3, 0. We'll go ahead and plot those. They'll be symmetric. There's 3. There is 7. Notice that those two roots are symmetric across that y-axis. I do have my vertex up there at 5, 4. And now we can connect the dots. Everything should fit in place with how it should. We've got roots. We've got our y-intercept. We've got our vertex. It's symmetric. My parabola is very sloppy. But we have all the key information. More importantly, we have everything about this graph and how it relates to the bottom with vertex, x-intercepts, y-intercepts. Last part, play doctor, domain and range. X is equal to all real numbers, and y, once again, we have in this case, we have a maximum y value. Once again, nothing on y is going to get any bigger on y than our vertex, and that's going to be at positive 4 this time. It's the y value of the vertex. So y, this is a maximum. Y will be smaller than, less than or equal to, positive 4. Okay. Another thing I did show you right there was how to convert from standard form into vertex, into intercept form. Next up, an equation they give us in vertex form. That's the big information that you need to know on this one. We're looking at f of x equals 2x plus 2 times the quantity, x plus 5 squared, minus 8. We still need the same information here. Vertex, axis of symmetry, domain and range, x-intercepts, and y-intercepts. Now, what I really like about vertex form is the information they give me for free. In vertex form, they give me the vertex for free. That will be opposite x. X plus 5, negative 5. Same y. Same y. This is vertex form. They've given me the vertex for free. Negative 5, negative 8. My axis of symmetry is the x value. I'm going to go ahead and plot this right now. Negative 5, negative 8. My axis of symmetry, I'll draw in. We have that. This is x equals negative 5. Now I need my x-intercepts and my y-intercept, and then my domain and range. So, the way I do it, we know that our x-intercepts are when y equals 0. Our x-intercepts are when y, or f of x, equals 0. So I will substitute 0 in for my y value, and I will solve the equation for x. Add 8 to both sides. 8 equals 2 times x plus 5 squared. I will divide both sides by 2. 4 equals x plus 5 squared. I will square root both sides. When I square root both sides, I will put a plus or minus. So now I have x plus 5 equals plus or minus 2. Minusing 5 from both sides of this equation, that will say x equals negative 5 plus or minus 2. So my roots are negative 5 plus 2 and negative 5 minus 2. So my roots, my x-intercepts, are at negative 5 minus 2, which is negative 7, negative 5 plus 2, which is negative 3. Notice they are equidistant. They are symmetric across my axis of symmetry, which is 5, which is 5, negative 5, negative 5. Put my roots on there. negative 3, negative 7, negative 3, negative 7. I've got my x-intercepts. Those are also my roots. They're called the zeros. Almost done with this bad boy. All I got to do is figure out my y-intercept now. If I can erase the board. There we go. My y-intercept. My y-intercept is going to be when x is 0. When x is 0, let's see, our roots were, I accidentally erased those. Again, my y-intercept is when x is 0, so I need to figure out what this is going to be when x is 0. So 2 times 25, that's 5 squared, minus 8, 50 minus 8 is positive 42. So my y-intercept, or when x is 0, 0, 42, which for me is way the heck off this graph. And I'll mirror that over too. Way the heck off my graph. Remember, that's up there at 42. We can go ahead and connect the dots and graph this bad boy. We've got our vertex, our roots, our y-intercept. Our vertex, our roots, our y-intercept. Last thing we need to do is play doctor. X is all real numbers. My range is my maximum or minimum value. In this case, I have a minimum value. My value of y is never going to get any lower than negative 8. So y will be bigger than or equal to negative 8. Again, my minimum value is at negative 8 there. I'm going to skip that one. I'm going to go into this one. I want to go sketch the graph of y equals 2 times the quantity x plus 7 times x plus 3. We're going to go ahead and sketch this one. This you should recognize is an intercept form. We still need the information. The catch is to know what information we get for free, what information we have to find. Hopefully, y equals 2 times the quantity x plus 7 times x plus 3. You guys are now starting to see the pattern here. That's given to me in factored form. That means I do have a root here at negative 7, 0, and I do have a root at negative 3, 0. That comes from opposite x, opposite x. Those are our roots. My roots, negative 7, negative 3. Mr. Wood, how am I supposed to find out what my axis of symmetry is? What's my vertexes? Give me a formula. You don't need the formula. Use your brain. Your axis of symmetry has to be halfway between your roots. It has to be symmetric. So if you have a root at negative 7 and you have a root at negative 3, that means your axis of symmetry in this case has to be at x equals negative 5. If x equals negative 5, that's also the x value of your vertex. Well, how do I find the y value? Plug it in, plug it in. Y equals 2 times negative 5 plus 7, negative 5 plus 3. Plug in negative 5 for x. Why did I plug in negative 5? I need to find my vertex. Y is going to equal 2 times. That's 2. What do we got? Negative 2 there. So y is going to equal negative 8. So my vertex is at negative 5, negative 8. Hey, Mr. Wood, I'm pretty much almost done with this problem. You mean if I just know what I'm talking about, and I can look at the equation and recognize what form it is, it's in, and get it, what information I have for free, I don't have to do much work for this stuff? Is this the same thing you've been telling me all along? All right. Last piece of information we need, our y-intercept. Our y-intercept is when x is 0. Our y-intercept is when x is 0. Substitute, simplify. Y is going to be a big number in this case. That's, 6 times 7. Y is going to equal 42. So our y-intercept is up there at positive 42. So our y-intercept is off the board here at positive 42. Positive 42, way over here. I accidentally deleted the zeros. Here we are, -7 and -3. Our vertex, -5, -8, -5, -8. And we can connect the dots at this point. Vertex, root, y-intercept. Vertex, root, y-intercept. Last part, play doctor, that's domain and range. Domain, x equals all real numbers. Range, determine if you have a maximum or minimum. In this case, we have a minimum y value, and y has to be greater than or equal to -8. All right. Oh, what about this one? Mr. Wood, y equals -x times x minus 4. I don't know what happens on this one. Yeah, you do. This is intercept form. It's a tricky way of looking at intercept form. Let's take the information we got. That's opposite x, opposite x. Opposite x there. Or using zero product, -x equals 0, x equals 0. Opposite x there, x equals 4. Those are our roots. 0, 0, and 4, 0. Those are our roots. 0, 0, and 4, 0. I still need the vertex, axis, symmetry, domain, and range, and y-intercept. Mr. Wood, how do I get that from there? Well, relax. I've already given you the y-intercept. It's the same as the x-intercept. If my parabola touches my x-axis at 0, 0, it also touches the y-axis at 0, 0. But what about the vertex, Mr. Wood? I don't know where that is. Yeah, you do. It's halfway between our roots. So our axis of symmetry, x equals 2. Our x value of the vertex is x equals 2. Plug it in. Oopsie. Y equals a -2 times 2 minus 4. Y equals -2 times -2. Y equals +4. So our vertex is at +2, +4. +2, +4. I'm going to use a daisy there. +2, +4. Let's see. This parabola originally said negative. That means it was opening down. It matches what I see there. That means I can connect the dots. Vertex, root. Vertex, root. Our root is also our y-intercept. Play doctor. X is all real numbers. We have a maximum value here. All our values of y are lower than that. So in this case, y is going to be less than or equal to +4. That one was kind of easy. Yeah. When you know what you're talking about, you see how this stuff fits together, it's supposed to be. That's all I got for you. Good luck. Let me turn this thing off.